Hi, this is Paul. We're doing Leetcode must-know interview questions. Today's challenge is contains duplicate 2. I don't remember doing contains duplicate 1, but the challenge here is given an integer array, nums, and an integer k. Let me scoot this over so you can see the method signature. Okay, so it's right here. Contains nearby duplicate is the method name. Input is an array of integers and an integer whose use we will talk about here. So we've got an integer array nums and an integer k. Return true if there are two distinct indices I and j in the array such that nums I and nums j nums I equals nums j and the absolute value of I minus j is less than or equal to k. So we've got to find matching numbers that are within k indexes or indices of each other. Let me kind of walk through this a little bit. Well, actually, first let me talk about a way that you could do it, but you wouldn't want to do it that way. Let me scroll this down. All right, so num's length, the length of the input array, is between 1 and 10 to the 5th. What is that? 100,000. All right, the nums are int size numbers. K is between 0 and 10 to the 5th. I wonder how that works with 0. Well, all right, but here's what you could do, obviously, is just take the first number in the array and then start iterating through the rest of the array until you find a number that matches, and then you say, well, is that within k indices? And if it is, you're done. It's true. If it's not, if they're too far away, well, actually, let me say it another way. Yeah, if they're too far away, then you take the index of the new number, the second number that you found, the matching number. And we're going to try to find another number that matches that number and is within k indices. And actually, example 2 is an illustration of that. That is, the first number is 1. Now, if we go through the array here and find a matching number, it is, let me get something to write with here. So first we have right here 1, and then we go through the array and we find, oh, here's another number that matches, also 1. Is it within one index? No, it isn't. So the indices are 0 and 2. All right, so the 0 index is of no use anymore. Okay, we got to get rid of that. But we can keep going, and here we do find another matching number. Now the indices are 2 and 3, and that is within 1. Okay. This algorithm is not going to work. I mean, it's not going to work efficiently. It's going to be, you're going to need a nested loop. It's going to be an O of n squared algorithm, and the length is up to 10 to the 5th, what is that? 10 to the 5th, yeah, 100,000. So n squared, 10 to the 5th squares, 10 to the 10th. Now we have 10 zeros, so it's 10 billion. Is that right? Yeah, it would be 10 billion. Okay, you don't want to do 10 billion operations. I mean, for these examples, you know, you can solve them any way you want because the arrays are so small, but a nested loop approach to this is not going to work. So let's think about another approach that that might work. So we could do it in O of n if we have a way to remember the numbers and the indices as we go along, and we do. We can do it with a hash map. So let's look at example 1 here and say, all right, let's start with 1. Now we look in the hash map, and I'm oversimplifying this a little bit, but it'll be well, you'll see the nuance in the code. We look in the hash map. Is there a 1 in the hash map? No. So we're going to put 1 in the hash map. And we're also going to put the index, which is 0. All right. Go to the next number, 2. And then we look and see, is 2 in the hash map? 2 is not in the hash map. So we're going to add 2 to the hash map and the index of 2. Next number, 3. Is 3 in the hash map? No. So we're going to add 3 to the hash map and the index. Go to the next number, 1. Is 1 in the hash map? It is. It's right here. So we look up the index of 1, and it's 0. And our current index is 3. 3 minus 0 is 3. Is that within our bounds here? K equals 3. It is. So we can return true. Okay. So there's an O of n approach with a hash map. Let's see what the code looks like. Okay. We need a map of integers to integers, integer to integer. Let's just call it hash map equals new hash map. All right. I don't think we need anything else. I think we can just start iterating through the array. So let's say for int I, actually instead of I, because we're using this for, we're using this as the current index. So actually I is not the best name for the way we're going to use it. It's not just like an anonymous, looping index. So let's say int current index equals 0. Current index is less than nums length. Current index plus plus. All right. Now we're going to get something called, oops, typo here. We're going to get something called, let's call it previous index. It might make more sense in a moment why we're going to call it previous index, because we're always going to be looking backwards. So in the example, when I sketched it out, when we found 1 in the hash map and got the index, that was the previous index of the number that we were looking for. So the previous index is Hashmap, and we can say get or default. This is what we left out of the sketch, the solution by hand, but we're going to say get default nums current index. But if it's not there, because we're going to use this in a computation, we got to have something. We got to have some kind of a number. So let's make it a number. So I mean, if the numbers can go up to 10 to the 5th, let's do negative 1 million. All right, that's completely out of range. All right, now we do this. If current index minus previous index is less than or equal to k, then we are done. We found a match, and it's within the given range. If we found a number and it's not within the current range, or we just didn't find the number at all, then we're going to put the current number, in the hash map along with the index. So let's say hash map put, let me just copy it. Put num's current index and current index. All right. Now, it's possible that we could go through this whole for loop and fail to find matching numbers with indices that are within the given range. If that happens, then we'll return false. All right, let's run it and see what happens. All right, that is accepted. That's just the basic cases. Let me give myself a little more space here and submit. What do we have here? Runtime. Runtime is not great. Memory is not great. Wait a minute. Oh, I see. Runtime beats 1497. Well, okay. But everybody had like about the same runtime. Right? What did we have? 25 milliseconds? But it all just peaked in that one place. So really it looks like everybody did it the same way. The memory is even worse, but let's see. Ooh, yeah, some people did do it with a lot less memory. Again, I do these things in Java, and I mean, there are more memory-friendly languages than Java. So, I mean, I'll take it. Analyze complexity. It's O of n. And that's it for, what was this called? Contains duplicate 2. Okay, hope you enjoyed it. Please feel free to like, subscribe, and see you next time.